All right, so picking up where we left off yesterday, we're going to look at quartic function, and a quartic function is a fourth degree polynomial. And so it's just a polynomial that has a highest degree of 4. And then turning points are where the graph of a function changes from increasing to decreasing, or decreasing to increasing. And it's where your extrema are located. So it's your relative and absolute minimums and maximums. All right, so looking at zeros and turning points of polynomial functions, a polynomial function of f function, I can't read that, f of degree, where your degree is something greater than or equal to 1. The turning points is going to be that degree number minus 1. So if you have a fourth degree function, you can have at most 3 turning points. Does that mean that you have 3 turning points? No. Right, you have a possibility of 3. And how many zeros can you have if you have like a fourth degree function? At most you can have 3 or 4. For the number of the power determines the number of possible zeros. Oh. Kind of like it when it's quadratic, when we factor it, at most x can equal 2 different numbers. And it has two zeros. And your zeros are where it crosses the x-axis. Sometimes they're also called roots. I guess I can start this slide. Alright, so in example 3, it says zeros in polynomial functions state the number of possible real zeros and turning points of f of x equals x cubed plus 5x squared plus 4x. Then determine all of the real zeros by factoring. So this one has a degree of 3. So at most, how many turning points are we going to have?
2.
2. So at most 2 turning points. And how many, at most, how many zeros will we have? How many times will it cross the x-axis? 3. So to find the zeros are when the y value equals 0. So we're going to set our equation equal to 0. And we're going to factor this. So looking at that first, do we have any greatest common factors that we can remove? Greatest common, we can remove an x because each term has an x. So removing an x, then we have x squared plus 5x plus 4 equals 0.
So it comes to 4, or x plus 4 and x plus 1.
Yep. So we need 2 numbers that when we multiply them together we get 4, but when we add them together we get 5. So now we have x times the quantity x plus 4 times the quantity x plus 1. So now solving, if this x that we pulled out initially is 0, then the whole thing is 0, right? Because 0 times 0 is 0.
Yes.
So x equals 0. And then if this parenthesis, if x plus 4, if that parenthesis equals 0, then the whole thing is 0. And if x plus 1 is, if that parenthesis is 0, then the whole thing is 0. So we're going to set x plus 4 equal to 0 and x plus 1 equal to 0. So solving, we have 3 zeros, and our 3 zeros are x equals 0. And then what's this 0 going to be? When we solve for x, we get negative 4. And then this 0 is negative 1.
So then is that x that we factored out, if that was like a number that we factored out, then we don't have to.
It doesn't matter.
Like, because like for that one we have like, but it's like x equals 0 because we have to have that x up front.
Right.
But if there's a number out front, we don't have to do that.
We don't have to do that. right, so questions on zeros and polynomial functions? Do we want to graph that to verify?
No.
We're okay? Alright, if you're not sure, you want to take the time to verify, you can just go onto Desmos and plug it in. Alright, so now we're going to look at quadratic form. And so this is looking at things in like the, x squared, a squared, something where your highest power is 2. Now, sometimes you have, and it's really small, but sometimes you can use substitution to make a higher polynomial function. You can, if it has 3 terms, and depending on the situation, sometimes you can use substitution to make it a quadratic so that the factoring is easier. And so that's what we're going to do in example 4, is we're going to use that substitution method. So zeros and polynomial functions in quadratic form state the number of possible real zeros and turning points. So here we have h of x equals x to the 4th minus 4x squared plus 3. And then we're going to determine all the zeros by factoring. So looking at this, what's our highest power? 4. So how many turning points can we have?
3. Well, 4 zeros.
Right. So turning points at most 3. And then at most 4 zeros. All right, so looking at this, it doesn't look like a quadratic, but how many terms do we have? We have 3 like a quadratic. So what we're going to do is we're going to substitute. We are going to let u equal x squared. So any place that there is a x squared, what are we going to put in there? U. So looking at this, x to the 4th, that's the same as x squared squared, correct? Because we have, when we square a square, it's multiplying the exponents. And then we have 4x squared plus 3 equals 0. Alright, so now, wherever there's an x squared, what letter are we going to put in? U. So in for x squared, we're going to put u, and then remember that's squared, so now we have u squared, minus 4u plus 3 equals 0. Are we okay so far? Alright, so now, can we factor this? Like a normal quadratic? Yes. So what are 2 numbers that when we multiply them together we get 3, but when we add them we get negative 4? Alright, so when the parenthesis u minus 3, when that parenthesis equals 0, then what do we know about the whole thing? It equals 0, right? And when this parenthesis u minus 1, when that equals 0, the whole thing is 0, right? Alright, so I'm going to set that up. So I have u minus 3 equals 0, and u minus 1 equals 0. Now before I solve, I need to remember that I substituted here, correct? Well, I'm gonna change it back now. So I have x squared minus 3 equals 0, and x squared minus 1 equals 0, and now I'm going to solve for my roots. So when we solve this, we move the 3 over and we get x squared equals positive 3, correct? How do I undo the square? I'm going to square root both sides. Now when we square root both sides, how many answers do we get?
2.
We get 2. So now we have x equals plus or minus the square root of 3. And for this one, we get x squared equals 1. And we need to square root both sides. How many answers do we get when we square root? So we get x equals plus or minus 1. So how many roots do we have for this one? We have 4. We have plus or minus the square root of 3, and then we have negative 1 and positive 1. Alright, so in example 5, we're going to look at zeros and polynomial function in quadratic form. Is that the one we just did? No. Alright, so then determine all the real zeros for factoring. So we're going to take what we did in example 4 and take it to the next level. So here we have x to the 4th plus 5x cubed plus 6x squared. So what do all the terms have in common?
An x, 2 x's.
They all have x squared. Oh, what's the most zeros that we can have? 4, and how many turning points? 3. So we can take out x squared. So then we have x squared plus 5x plus 6. So we need two numbers that when we multiply them together we get 6. Same two numbers when we add them together we get 5.
Two and three.
Alright, so we don't have to do any substituting since it was already in quadratic form. So we have x squared, and then if x squared equals 0, then the whole thing is 0, right? Yep. If the quantity x plus 2 is 0, then what's true about the whole equation?
Wait, what is x plus 2?
Yep, if that
Negative
parenthesis.
2.
So that's going to give us a 0 of negative 2. And then if this parenthesis is 0, if x plus 3 equals 0, then it's, the whole thing is 0. Now, we have to square root our 0, but does 0 have a sign? Is it positive or negative?
No.
No, so we have how many zeros? How many roots? 3. We have negative 3, negative 2, and 0. And like all the other ones, to verify, we can plug these numbers into our original equation and it should equal 0. We can graph it as where our graph is crossing the x-axis. Alright, questions? Alright, let's look at example 6. So the next concept we're going to look at is multiplicity. And a few years ago, probably going on 20 years now, there was a movie called Multiplicity. You ever heard of it?
Nope.
Okay. So in the movie, the character, he multiplies himself because he has so much to do, so he makes clones of himself. And so there were multiples of him. And so with multiplicity, in algebra or pre-calculus, multiplicity is the same thing. It's when you have multiples of the same quantity. So if we look at, in example 6, we have x minus 2, and that thing is squared. So we have 2 of those. So it has a multiplicity of 2 because we have it squared 2 times. And that affects the graph. When you have when your multiplicity is of an odd number, it's going to cross the graph. When you have a multiplicity of an even number, it's going to touch the graph and then come back down. So if you have an odd multiplicity, it'll just kind of go through and look like that, almost kind of normal. But if you have an even multiplicity,